My name is Alberto Velamartin. I work at the Center of Applied Space Technology and Microgravity, and I do research on computational fluid mechanics. In this jar we have two liquids, one that is oil and water, and they are immiscible, so they don't like to mix into each other. But in some applications you might want to make them look like they are mixed, and you produce something that is called an emulsion. The most typical case is mayonnaise, which in the end is just water with very small drops of oil. Actually so small that you cannot see them, and the thing looks like white from the outside. And the idea is that you produce this emulsion, or you produce these very small drops by shaking the content of the jar very fast. You produce turbulence, and turbulence breaks these drops and make them very small. So the most important finding in our paper is that, it was believed before that in an emulsion, drops would become smaller and smaller in the fragmentation process, and that fragmentation process would eventually stop when the diameters of drop would go below a certain length. And we found out that this is not true, that drops can always break, only that they might take long time for them to break. So that means there is a non-zero probability of breakup even below the limit diameter that was in the previous and most accepted theory. And this is a very important finding because it implies that there is a change of paradigm in the field of drop breakup in turbulence.